and welcome to week 14 of quadratic Quant questions. This week we'll be handling questions based around quadratic equations or quadratic expressions, or even perhaps cubic, but I'm including them all together with quadratics. There's going to be, of course, one more sheet of quadratics. Let's look at the questions. The roots of x cubed, px squared, qx plus r equal to 0 are consecutive positive integers. Which of the following can never be the value of q? Okay. Let the three consecutive positive integers here be a plus 1, and a minus 1. Now, p is equal to negative sum of roots. So, minus a minus 1 plus a plus a plus 1, or b is equal to minus 3a. Q is equal to positive sum of pairs of roots. Positive sum of pairs of products of roots. First two roots, they multiply to give us a square minus a. Next two roots multiply to give me a square plus a. And finally, the first and the last root multiply to give me a square minus 1. Or altogether, here I get 3a square minus 1. 3a square minus 1. Okay. Now, R definitionally is simply product of roots. If these three numbers are multiplied, we get a cube minus a. Now, we have been asked which of the following can never be the value of q. Which of these can never be a value of q? 3a square minus 1, can it be equal to 47? It would imply 3a square is 48. If 3a square minus 1 is equal to 47, this would imply 3a square is equal to 48, or a square will be equal to 16, or a will be equal to 4. So this is an acceptable case, which means this cannot be the answer. How about 11? 3a square minus 1 is equal to 11. 3a square is equal to 12. A square is equal to 4. Or a is equal to 2. This is also possible. This cannot be the answer. For option C, 3a square minus 1 is equal to 107. 3a square is equal to 108. Or a square is equal to 36, or a is equal to 6. This is also possible. This is not possible. By elimination, what is left is 27. You could also perhaps have reached this result. Look at the value of q. It is always some multiple of 3 minus 1. Some multiple of 3 minus 1. This is a multiple of 3 minus 1. This is a multiple of 3 minus 1. This is a multiple of 3 minus 1. This, however, is a multiple of 3 itself. So this can never be the value of q. The answer to the question is option D. Next, fx is a polynomial in x of degree 7. The coefficient of x raised to the power 7, x raised to the power 7 in fx is 1. f1 is equal to 5, f2 is equal to 7, f3 is equal to 9, f4 is equal to 11, f5 is equal to 13, f6 is equal to 15, f7 is equal to 17. Find f8. Now, hopefully you realize if it's a polynomial here in x of degree 7, this is how the expression would look like. Seven, 6, 5, 4, 3, 2, 1, and 0. Some constant. This is how the entire expression would look like. Additionally, Additionally, given that this is a polynomial in degree 7, there are 7 linear terms that are multiplying. We'll have x minus root 1, or let's call the roots a, x minus a1, x minus a2, plus x minus a3, x minus a4, x minus a5, x minus a6, and x minus a7. This is how a standard polynomial with 7 roots will look like. But understand, when you this subsequent portion of the question, f1 is equal to 5, f2 is equal to 7, f3 is equal to 9, f4 is equal to 11, f5 is equal to 13, f6 is equal to 15, f7 is equal to 17. The values are increasing in steps of 2 here. The values are increasing in steps of 2 here, which means although this is a polynomial with a degree of x being 7, there is also a part to the expression. There is also a part to the expression that is linear in nature. By linear in nature, I mean it increases in steps of 2. So I can write down this entire expression. I can write down this entire expression as some linear part of that expression. And now, see this wonderful thing. See this wonderful thing. There are 7 numbers that are multiplying. There are 7 numbers or 7 brackets that are multiplying and a linear quotient. It is giving me 5 and 7 and 9 and 11 and 13 and 15 and 17. I can go on to say, sorry, only this linear part is giving me this 5 and 7 and 9, 11 and 13 and 15 and 17. This portion gives me 0. How would it give me 0? If either K1 or K2 or K3 or K4 or K5 or K6 or K7 is 1 or 2 or 3 or 4 or 5 or 6 or 7, essentially what this is turning into is now a combined expression where I will get these particular values for F1, F2, F3 will be like this: x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, x minus 6, x minus 7, plus it starts off with 2x plus 3. Now see, if you put down the value of x equal to 1, the first set of brackets would be 0, and then you'll get 2 into 1 plus 3, 5. If you put down x as 2, the first set of brackets will give you 0. 2 into 2 plus 3 will give you 7. If you put down x as 3, the first set of brackets will give you 0. 2 into 3 plus 3 will give you 9. So this expression is the final form for this polynomial. Now, for this polynomial, we were expected to find f8. So we are essentially finding 7 into 6 into 5 into 3, sorry, 4 into 3 into 2 into 1 plus 16 plus 3. 7 factorial is 5040 plus 19. Altogether, we will get 5059, which is the final answer to this question. This is a very typical question. It should ideally not need for you to write down these expression forms. Straight away for solving, we directly jump to this expression because we have hopefully seen this question type several times. Okay. Next question. Now the number of non-real roots of the equation x cube minus 2x square minus 2x minus 3 is equal to 0. Hopefully we realize 2 things. One, Descartes' rule of sign is not really needed for CAT. Second, when we are looking for roots of a cubic equation, our first go-to move always has to be to open, pray, and appeal to higher authority. Please give me one root. Please give me one root so that we can progress further. And when you are trying to fit in numbers here, the set of numbers that you should be fitting in go from 0, 1, 2, 3, 4, 5, and -1, -2, -3, -4, and -5. These 11 numbers, you have to check them sequentially in order to see if one of them turns out to be the root for this given equation. Okay. Putting it down. I'm checking 0. No. I'm checking 1. 1 -2 -2 -3. No. X equal to 0 doesn't work. X equal to 1 doesn't work. X equal to 2. It's 8 -8 -4 -3 doesn't work. X equal to 3. 27 -18 -6 -3. And yes, this does work. So one of the roots has been identified as 3. One of the roots has been identified as 3. If one of the roots has been identified as 3, we can simplify this equation as x minus 3 into x square plus 1. See, x into x cube will x into x square will give me the x cube quotient, and minus 3 into plus 1 will give me the final constant quotient. Now for the middle term, whether it is plus or minus, we will figure it out together. Minus 3x square, but I finally need a minus 2x square. So this quotient here will be plus x. You can also see minus 3 into x, minus 3x, plus x. So yes, this expression will simplify to this. And now, see, this is a real root. This is a real root. One first real root has been identified. Now, for this portion, this is a quadratic now. For quadratic, to check whether there are real roots or unreal roots, we have to look at the discriminant or b square minus 4ac. B square here is 1. 4 times of ac is just also 1. So 1 minus 4 is equal to minus 3. When b square minus 4ac is less than 0, then the roots are unreal. So there are 2 non-real roots. Here, there is 1 real root here. So the number of non-real roots for the equation, this is 2. There are 2 non-real roots for this equation. Also, hopefully we know non-real roots always come in conjugate pairs. Non-real roots always come in conjugate pairs when the coefficients are real. If all the coefficients of the quadratic equation or cubic equation or the expressions are real and there is one unreal root, the other conjugate unreal pair number will also be a root. Okay. Next question. What is the remainder when x raised to the power 87 plus x raised to the power 69 plus x raised to the power 51 plus x raised to the power 33 plus x raised to the power 15 is divided by x cube minus x. Okay. According to the remainder rule, product rule, whatever we choose to call it, let's call this fx. Fx is equal to this expression. Fx should be equal to some multiple of x cubed minus x plus, now see, this is a cubic equation, this is a cubic expression. So the remainder that will be left will be a quadratic equation. Ax square plus x plus c. This will be the remainder left. This will be the remainder left. For fx, some multiple of what you're dividing it by, and what is left over is some quadratic, because you're dividing it by a cubic, whatever will be left over will be a quadratic. Okay. Now that we have this, what we can do is, let's put down for x equal to 0. X equal to 0. Can you see your LHS will be 0 and your RHS This portion is entirely divisible. This is the remainder. X square will be 0, bx will be 0, c will also be 0. At x equal to 0, we get this. Understand, we have to figure out values of a, b, and c in order to figure out the total coefficient. But this will be 0. Wonderful. At x equal to 1, each of these expressions will turn 1, 1, 1, 1, 1. 5 is equal to a plus b plus c. Now understand, ABC is, as in C is already 0. This is actually as good as 5 is equal to A plus B. This is known. At x equal to minus 1, at x equal to minus 1, okay? Minus 1, minus 1, minus 1, minus 1, minus 1. So minus 5 is equal to A minus B. A minus B. C will of course remain missing because C is equal to 0. Now see, A plus B is 5. A minus B is minus 5. When we add both these sides up, we get 2A is equal to 0 or A is equal to 0. If A is also equal to 0, B has to be equal to 5. If B is equal to 5, look at this remainder portion. Ax square, A is 0, so it is no longer considered in our remainder consideration. C is 0, no longer considered in our remainder consideration. Finally, we are left with B equal to 5. So the remainder that is left is 5. There is one way of solving, and there is the technical way of solving. The other way of solving that I'm guessing most people would be familiar with this. If I'm dividing it by something minus something, I can reduce this expression tremendously. I can reduce this expression in steps. Let me write it down. X raised to the power 87 plus x raised to the power 69 plus x raised to the power 51 plus x raised to the power 33 plus x raised to the power 15. If I'm dividing it by x cube minus x, the way to do it is replace every x cube with x. You can replace every x cube with x. So first, I'm only trying to solve for this first expression. This will turn to x cube turns to x. So this will turn to x raised to the power 29. X cube raised to the power 29. X cube becomes x cube. I can reduce it straight away. Then this will turn to x cube. Let me not skip over steps because people will be troubled. Let me write it. X cube raised to the power 29. So it will turn to x raised to the power 29. This will be x cube raised to the power 9 into x square. So x raised to the power 9, x square will turn to x raised to the power 11. X cube raised to the power 3 into x square. So it will turn to x raised to the power 5. X cube into x square. X cube turns to x. So this will turn to x cube, which will finally turn to x. This entire x raised to the power 87 is as good as x when it comes to remainder finding with x cube minus x. X raised to the power 87 leaves the same remainder as x leaves with x cube minus x. So this leaves a remainder of x. Now let us do the same sort of processing for the second expression. X cube raised to the power 23, x raised to the power 23, x cube raised to the power 7 into x square, so get to x raised to the power 9, x cube raised to the power 3, x into x cube, gets me to x. Okay. I think I should space it out a little bit because these things require a lot of space. Now here will come down to x raised to the power 17 because x cube raised to the power 17 then it will come down to x cube raised to the power 5 into x square or x raised to the power 7. Then x cube square into x, it will turn to x cube or it will turn to x. This is also done. This will come down as x cube raised to the power 11 or x raised to the power 11. Now, as soon as I see x raised to the power 11, I know the journey after x raised to the power 11 from the first expression. Journey from x raised to the power 11 gets me to x only. So I will directly write x. And for the final term, I have x cube raised to the power 5 or x raised to the power 5. I know my journey from x raised to the power 5 is only till x. So I will directly write x. So essentially, in terms of remainder, what am I left with? An x in each instance. And these remainders are separated by a plus sign. So what will be the final remainder? It is going to be k. This is using the remainder rule using polynomials, and the earlier one was the more technical way of solving. Both these ways are fine. It is just that the first one takes lesser time, this one takes slightly more time. Okay. Next question. A certain person bought a number of oranges for rupees 70. The price of each orange, if the price of each orange was too less, he would have bought 4 more oranges for the same amount. The number of oranges he bought originally is. Okay. Let him buy quantity and the price. Let this be x, let this be y. X into y is equal to 70. If the price of each orange was too less, y minus 2 into x plus 4 is also equal to 70. This is what we know. So now see, you can solve it via quadratic equations, or you can solve it via simple number theory understanding. We are looking for factors of 70. Because this is a data question, the answer will of course be integral. We are looking for factors of 70 that differ by 4 and differ by 2 here, pairs of factors. Equally, you can see 1 by 70, 2 into 35, 5 into 15, 7 into 10. And this is it. These are all the factors. For these two pairs, hopefully you can see the relationship. If you had 7 here and 10 here, 14 here, and 5 here, your work is done. Your work is done. The number of oranges he bought originally is 10. Simply by listing out pairs of factors of 70, our work can be done. But because this is with quadratic equations, this should be solving it quadratically as well. Xy is equal to 70 and xy plus 4y minus 2x minus 8 is equal to 70. So we have 4y minus 2x is equal to 8, or 2y minus x is equal to 4. We have this equation. From here we will get x is equal to 70 by y. Put that here. 2y minus 70 by y equal to 4. So 2y square minus 70 minus 4y is equal to 0. I can again get rid of 2's final equation I'm dealing with is y square minus 2y minus 35 is equal to 0. So y minus 7 and y plus 5 is how this will break down. So y is equal to 7 or minus 5. Given y was price, it cannot be minus 5. So the only acceptable value of y is 7. Once we identify the value of y as 7, then we can come up with the subsequent values, and then we can arrive at the answer 10. You can solve it via quadratic equations. You can also solve it via simply listing out of pairs of factors. Next question. Find the values of k for which the roots of x square plus 4, x square plus x times of 14 minus k minus 14k plus 1 are equal integers. Now understand, if the roots are equal integers, product of roots will be a perfect square. Product of roots will be a perfect square. So I'm simply checking. See, the product of roots here is minus 14k plus 1 minus 14k plus 1. So I'm putting down values from the options and checking where am I getting a perfect square. I'm putting down options for options and checking where do I get a perfect square. So if it is 14 into 11, minus 14 into minus 11, I get 154 plus 1, it becomes 155. I see this is not a perfect square. 155 is not a perfect square. So at this time, I can rule out option A, and I can also rule out option D. Cannot possibly be true. Cannot possibly be true. Okay. Then I have to check only one of these two options. I'm checking down 12. Checking 12. Minus 14 into minus 12 gets us to 168 plus 1. This is equal to 169. This is indeed a perfect square. So 12 survives. Then let me put down 16. Minus 14 into minus 16 gets me to 224. 224 plus 1 is equal to 25. It is also a perfect square. So this should be the answer. This should be the answer. In terms of solving in the exam, this is all the work that one needs to do. Now, technically, if we are thinking about solving this, how we will do it is, if the, see, according to Sridharacharya method of finding the roots and everything, the x is equal to plus, minus b plus minus under 2a e square minus 4ac. Given that the roots are equal integers, what will we get here? B square minus 4ac should be equal to 0. B square minus 4ac should be equal to 0. So B square here is 15 minus k square minus 4 times of a is 1 and c is minus 14k plus 1. This should be equal to 0. So open up, you get 196 plus a square minus 28k plus 56k minus 4 is equal to 0. Or we get k square plus 28k plus 192 is equal to 0. Or k plus 12, k plus 16 equal to 0. So k is equal to minus 12 or minus 16. This is how the technical solving of this would take place. The other simple question is, product of roots must be a perfect square. Simply replace the options and check. In either case, of course, you will reach option B as the answer. Hopefully, the idea is clear. Okay. Next, again, if the roots of 2 raised to the power n x square plus 8x plus 64 raised to the power n are real and equal. Understand? They're not saying the roots are integral, they are saying real and equal. Find them. If the roots are equal, it can only happen if b square minus 4ac is 0. B square minus 4ac is 0. Here, there is no need for them to be a perfect square. Understand? Here, they were integers, so you had to get a perfect square. Here, even if it is not a perfect square, the world will still exist because they are simply called as real. But as long as they are equal, b square minus 4ac, the discriminant has to be 0. So let's go ahead. Discriminant here will be b square is 64 minus 4 times of 2 raised to the power m into 2 raised to the power 6m. This is equal to 0. So, 2 raised to the power 6 minus 2 raised by 2 plus m plus 6m, 7 plus, sorry, 2 plus 6m, 7m is equal to 0, which would mean 2 plus 7m is equal to 6, or 7m is equal to 4, or m is equal to 4 by 7. So the correct answer for this question will be option D. Okay, the second part of the solution now. If a and b are positive numbers, what is the nature of the roots of the equation? A plus b x square plus 2abx plus a plus b whole cube divided by 16 is equal to 0. This a plus b x square plus 2abx plus a plus b whole cube divided by 16 is equal to 0. If we're looking at nature of roots, of course, you have to look at the discriminant. So discriminant here would be b square or 4a square b square minus 4 times of a plus b into a plus b divided by 16. We have to look at this value, whether it is greater than 0, less than 0, equal to 0. Okay, this you have to look at. Let's go ahead and check. First thing we will have is this, and this I can cancel. So the expression comes to 4a square b square minus a plus b raised to the power 4 divided by 4. 4a square b square minus a plus b raised to the power 4 minus 4. Okay. One thing I see here, if I take a equal to b equal to 1, if I take a equal to b equal to 1, I would get 4 minus a plus b is 1, a plus b is 2, raised to the power 4 is 16 divided by 4, still 4. 4 minus 4 is equal to 0, which would mean the roots are real and equal. This case comes out. This case possibly comes out. But then I cannot mark B right away because there is an option that also includes B. So let me check some other case where A is equal to 1 and B is equal to 2. Then what am I getting? A equal to 1, B equal to 2 gets me 8 minus 1 plus 2 raised to the power 4. So 81 divided by 4 minus 20.25, which gets me a negative value. So the discriminant could either be 0. In one case, it is turning out to be 0. In one case, it is turning out to be negative. When the discriminant is negative, you get non-real and distinct roots. You get non-real roots. Both these cases are possible, and the correct answer, therefore, here should be D. Now, here I have gone ahead and checked it by putting down values for A and B. The technical way of understanding this, or the technical way of solving this, would be as follows. Okay. You simply have to look at this expression in a slightly different way in order to arrive at that. First thing we do is we write down 2ab whole square minus a plus b whole square by 2 whole square. Hopefully you can see I've got 2ab and a plus b by 2. A plus b whole square by 2 and 2ab square. This should give you a very AMGM vibes. This should give you very AMGM vibes. What I'm doing is I'm dividing both sides by a plus b whole square, and also this expression by a plus b whole square. The left hand side expression will turn to 2ab divided by a plus b whole square minus A plus B whole square divided by, sorry, A plus B by 2 whole square. Can you see? This is GM of two variables AB. This is AM of two variables AB. And we know AM is always greater than equal to GM. When are they equal? When A and B are identical. When is the GM smaller? When A and B are not identical. Utilizing that, we can definitely confirm that the first expression will either be equal to the second expression or will be smaller than the second expression. And therefore, the result that you get here will either be 0 or less than 0. Because the result will be 0 or less than 0, both B and C possibilities exist. And we can go ahead and mark option D as the answer. But understand, while this is the technical explanation, for the purposes of solving in an exam setup, you can simply plug in values and check. You can simply plug in values and check. So checking for A equal to B equal to 1 and A equal to 1 and B equal to 2, that was more than enough for us to arrive at the answer. Okay. Next question. If the value of T in the equation x square plus 2 times of P plus 1 x plus 2P is real, then the roots of the equation are. If P is real, then roots of the equation. Again, look at these options. We're looking at nature of roots, and nature of roots is given by B square minus 4AC, whether it is greater than 0 or less than 0 or whatever. So we break it down. We get 4 times of 4P square plus 4 plus 2 into 2P plus 4P minus sorry, 2P. This will be 8P. This will be 8P minus 8P. This is the expression that we will get. Now this turns to 4P square plus 4. If this is 4P square plus 4, this has to be greater than equal to 0 because P square will be 0 or positive and 4 is always positive. Given that the discriminant is greater than equal to 0, given that discriminant is greater than 0, it will necessarily be greater than 0. The roots will necessarily be real and unequal. Okay. Next question. In a right angle triangle, the larger of the sides containing the right angle is 8 centimeters longer than the smaller of the sides. Okay. So if this is x, this is x plus 8. Sorry, x plus 8. The sum of lengths of the sides containing the right angle, this is x and 2x plus 8 is 16 more than the length of the other side. This is 2x plus 8 minus 16, or this is 2x minus 8. Now, the length in centimeter of the smallest side is. We can apply the Pythagoras theorem. These are the three lengths. All of them are in the same variable. We can apply the Pythagoras theorem. Get x square plus 64 plus 16x is equal to 4x square plus 64 minus 32x. 64 more. We get 2x square is equal to 48x. 1x gone, 1 is gone. Why I'm able to cancel it off happily is I know x is not equal to 0. So cancelling will not be a problem. I will definitely get x as a positive number. And therefore x is equal to 24. So I'm going ahead and also checking it. If this is 24, this will be 32, and this will be 40. Yes, this is the 3, 4, 5 triangle multiplied by 8. So this is perfectly all right. The length of the smallest side will of course be 24. Let's look at this question now. The roots of the equation 4x square plus 14x plus 3 are a and b. Find under root a by b and under root b by b. Okay. Interesting thing. This is a very, very tricky question and a lot of people get it wrong. First, I will do it the incorrect way and then I will show you what the correct idea has to be. See, the roots of the equation are a and b. If I look at this expression, I've got under root a by b plus under root b by A. If I make the bases identical, I will get under root AB. Now under root A multiplied with under root A and under root B multiplied with under root B will give me A plus B. So this is sum of roots. This is square root of product of roots. Sum of roots is minus 14 by 4 and product of roots is 3 by 4, but this is under root. So this gets us to minus 7 by root 3. Because all the options are with a denominator of an integer, this is as good as minus 7 root 3 by 3. You can go ahead and mark this answer, but then it will be wrong. Notice. We've got an under root term. When we are looking at these under root terms, the result that you should get should be positive. You cannot have negative result coming out of these two under root terms. So how is the sum turning out to be negative? It means along the way we have made a mistake. And the mistake is when I multiply under root A with under root A here, whether we will get positive A or negative A, or whether we will get positive A or negative, we'll get positive B or negative B, that is a challenge. And how is that challenge coming into being? Look at this. When you look at the roots for this equation, can you see sum of roots is minus 14.4 and product of roots is 3 by 4, which is an indication both roots are negative. Sum is negative, product is positive, both roots are negative. And see how that helps us is now A by B will be positive. Now B by A will be positive. But when I multiply root A with root A, it may not necessarily be positive A that we are getting. It could very well be a negative A that we are getting. So how we should be looking at this is under root mod A by under root mod B plus under root mod B by under root mod A. Because realize A was negative, B was negative, they cancel each other's negativity out and they become positive. But in this form, you don't really need that. What the final result will still be positive, but we are dealing with what this gets us to is we have mod A plus mod B by under root of mod A, mod B. Both roots are negative. Now see, this is as good as, because I know A and B both are negative, minus A plus B by under root of AB. AB I know to be product to be a positive value, but mod A plus mod B will be equal to minus times of AB because both roots are negative. And this will now give us the right expression, right value. Minus 14 by 4. All we have to do is simply change that. I can copy the entire thing from the top. Minus 14 by 4 divided by under 3 by 4. So this all I have to do is add an extra negative sign at the beginning, which would mean the final result that we are getting, their sign will be flipped. So the correct answer eventually that we get is 7 root 3 by 3, or the correct answer for this question is option C. This is a very, very important insight to note for solving this question, in the absence of which you will of course get it wrong. Okay, next, the roots of the equation x square minus 3x minus 108 equal to 0 are alpha and beta, where mod alpha is greater than mod beta. Which of the following holds true? Okay. I can happily see, given that alpha beta direct interaction is happening, I can look at the roots directly. X square minus 3x minus 108. I'm looking for two numbers that differ by 3 and have a product of 108. It is 12 into 9. So x square minus 12x plus 9x minus 108 equal to 0. X times of x minus 12 plus 9 x minus 12 is equal to 0. So x is equal to 12 or minus 9. These are the two potential values. We are told mod alpha is greater than mod beta. So this is alpha, this is beta. Finally, we are looking for alpha minus beta in every expression. So 12 minus 9. Or the final result will be 21, which is option D. Okay. Next question. This is also a very typical formation of a question. P and Q were trying to solve a quadratic equation. P copied the coefficient of x from. See, ax square plus bx plus c. This is the standard quadratic form. P copied the coefficient of x wrong. So this number is wrong. If this number is wrong, the sum of roots that you get, sum of roots is given by minus b by a, and product of roots is given by c by a. If this number is wrong, sum of roots will be incorrect, but product of roots will be correct. And the two roots obtained in this instance is 12 and 9, which tells us for the correct equation, product of roots is equal to 108. For the correct equation, product of roots is 108. Okay. Now, Q copied the constant term wrong. Q made a different error. He copied the constant term wrong. If he copied the constant term wrong, he will get product of roots incorrect, but he will definitely get sum of roots correct. Now, sum of roots is given by minus b by n. So, copied the constant term wrong and obtained 8 and 16, which means sum of roots equal to 24. Product of roots is 108. Sum of roots is 24. For which option? Find the roots of the equation. See two numbers that add up to 24. This doesn't add up to 24. This doesn't add up to 24. This doesn't add up to 24. This is the only one that adds up to 24. So this should be the answer. If they usually this question goes into what would be the correct equation? What would be the correct equation? Hopefully we know how to do that. We have product of roots, we have sum of roots. So we'll go ahead and write it down as with product of roots, sum of roots, you can get to the roots. So x minus 80, x minus 6. And then this will give us the equation. We can solve it from here. Okay. Next question. Roots of the equation ax square plus bx plus c are d less than those of the equation ez square plus fz plus g. And the roots of the equation py square plus qy plus r are d more than those of the equation ez square plus fz plus g is equal to 0. Which of the following is true? Now, the wonderful thing that you can note here, you can solve it via technical ways. Lots of technical ways for solving this most definitely exist. But if you can see that, how this is going about, you can do it in very, let's say, algebraic way, or you can do it in very logical way. Let the two roots of this equation be 0 and 0. Which would mean the equation I get here is x square is equal to 0. The two roots here are 0 and 0. It would be x square is equal to 0. Let d be 1, which means the roots here will be 1 and 1. For 1 and 1, the equation that gets created will be z square plus 2z plus 1 is equal to 0. The equation here is x square is equal to 0. Z square plus 2z plus 1 is equal to 0. Now, roots of the equation py square plus qy plus r are d more. Again, 1 more than those of the previous one. So, let the roots here be 2 and 2. Let the roots here be 2 and 2, which would mean we get y square. Oh, sorry. I've made a terrible mistake. This will not be plus 2z. This will be minus 2z. Minus 2z. Minus 4y plus 4 is equal to 0. And therefore, now look at x will take two potential values 0 and 0. Z will take two potential values 1 and 1. Y will take two potential values 2 and 2. Which of the following is true? Is 2 equal to 0 minus 1? Of course not. Is 2 equal to 0 minus 2? Of course not. Is 2 equal to 0 plus 1? Of course not. Is 2 equal to 0 plus 2? Of course, yes. This is the answer. This is the answer. Now, simply by allocating different roots, we can solve this. Or the technical way, or let's say the algebraic way, the academic way would be, let the roots here be alpha and beta. So the roots here will be alpha plus d. Here it will be beta plus d. And the roots here will be alpha plus 2d. And here it will be beta plus 2d. Now, the roots and roots direct comparison, you can see alpha y, the value for the variable y in this equation, is 2d more than the roots that you get for the equation with variable as x, and therefore you can mark this as d. So this is, might see, this is simpler. This is not the way most people think. Or at least I think, if you went ahead and allocated a value, it would be simpler to solve. At least I would have done it that way. Next, if the roots of the quadratic equation x square minus bx plus q equal to 0 are two successive multiples of 5, then the value of p square minus 4. You can see, I've been told two successive multiples of 5. Let the two roots be 0 and 5, which would mean the equation is x square minus 5x is equal to 0. So p is equal to 5, q is equal to 0. Final value of p square minus 4k will be 25. By simply taking two roots, I can reach my answer. If you want to solve it technically, it will be 5k and 5k plus 5. These are the two roots. So p is equal to 10k plus 5, sum of roots, and q is equal to 25k square plus 25k. 25k square plus 25k. Now these two I have to p square minus 4q if I have to. P square will be equal to 100k square plus 25 plus 2 into 5, 100k. From this I have to subtract 4 times of q, which is minus 100k square minus 100k. So this and this will get cancelled. This will get cancelled. Finally, I'll be left with 25, which should be the answer to this question. But as soon as I assumed 0 and 5, hopefully you could see solving this question was a kick. Next, if the roots of the equation x cube 6x square and 3x plus k are in arithmetic progression, the value of k is, okay, let the three roots here be a plus d, a minus d. Sum of roots will therefore turn out to be 3a. And sum of roots according to this expression, is 6. So 3a is 6. Or one of the roots is 2. As soon as one of the roots is 2, when I put 2 in this equation, I should get a result is 0. When I put 2 in this equation, I should get a result 0. So let me just go ahead and put it. 8 minus 6 into, so 24 plus 6 plus k is equal to 0, or this gives me k is equal to 10. Our work is done. If the question had asked me about other roots, even that can be asserted. Let's see. From this 3, if we want to solve it from this 3, I can go ahead and get it as from this 3, I know it is a positive sum of pairs of products. So I get a square minus a plus these two now, a square plus b, and finally these two plus a square minus b square. Cancel. we get 3a square minus a square. A square we already knew. A square we already knew to be 2. So this will turn to 12 minus b square is equal to 3. Or d square is equal to 9 or d is equal to 3, which means the three roots are 2, 5 and minus 1. 2, 5 and minus 1. We could also do that. Although the question only limited to asking about the value of a, they could also have identified the other roots. Okay, next. Find the respective values of a and k if the roots of the quadratic equation 27x square minus 87x plus k are a and 8 by 3. Okay, I have been given one of the roots. Let me just put that down here. So I will have 27 into 64 by 9 minus 87 into 8 by 3 plus k is equal to 0. Cancel 3, cancel 29. I get 192 minus 232 plus k is equal to 0 or k is equal to 40. As soon as I arrive at this point, I now know the answer has to be this. I needed values of a and k. Value of k I'm extremely certain of is 40, and this is the only option that has k as 40. So this has to be the answer. Now that we know the value of k is 40, we can go ahead and solve for this. We can go ahead and solve this and arrive at the value of the other root. We can go ahead and arrive at the value of the other root. But then it is immaterial. We don't really need that at all. Okay. Additionally, if I also want, let's say, value of a, I can say a plus 8 by 3 is equal to 87 by 27. So I get 27a plus 9 times 2 plus 72 is equal to 87. Or 27a is equal to 15 or a is equal to 5 by 9. We can be extra certain, but as soon as I arrived at value of k, no more solving was needed. Okay, let's go on. If the quadratic equation whose roots are reciprocals of the roots of 3x square minus 8x plus 4 is equal to 0. Find the quadratic equation whose roots are reciprocals. All you have to do is simply 3 times of 1 by x square minus 8 times of 1 by x plus 4 is equal to 0. So you get 3 minus 8x plus 4x square is equal to 0. This is positive, this is positive, this is negative. So answer will be option C. That's it. You can do it this way. Or another way you can do it is, given that the numbers are fairly straightforward here, you can actually 3x square minus x. 3 into 4 is 12, so minus 2x minus 6x plus 4 is equal to 0. So we get x, 3x minus 2 minus 2, 3x minus 2 is equal to 0. So x is equal to 2 or 2 by 3. If I'm looking for reciprocals as roots, my two roots will be half and 3 by 2, or the equation will be formed this way. 2x minus 1 to 2x minus 3. Remember, it is equal to 0. So 2, when it multiplies with 0, it will become nonsense. So I open it up, I get 4x square minus 2x minus 6x. 8x is equal to 0. Same work, but then this is longer. This is the shorter way of doing the same question. Next, the polynomial equation of the lowest degree with coefficients, with real coefficients. Its roots are 2 minus I root 5 and 3 could be. Okay. When we are saying real coefficients, it means all the imaginary roots that exist will exist in conjugate pairs. So if one root is 2 minus I root 5. There is also going to be another root which is 2 plus I root 5. These two are going to exist most certainly. If these two are going to exist most certainly, then now we have to figure out what will be the, see, 3 roots. Lowest degree, 3 roots. We need at least 3 roots. That is identified. Right now I'm looking at sum of roots. Minus I root 5 plus I root 5 will cancel. So 2 plus 2 plus 3. So sum of roots is 7. Here sum of roots is minus 7, minus 7. So these two options are out. These two are the only options left. Now in these two options, we can see product of pairs of roots, sum of product of pairs of roots is the only distinct term. Let's go ahead and figure that out. 2 minus I root 5 into plus I root 5. How much will they give us? 4 minus 5. Yes, 4 minus 5. Then 2 minus I root 5 into 3 will give me 6 minus 3I root 5. This will give me 6 plus 3I root 5. This will be 4 plus 5. By mistake, this will be 4 plus 5 because it will be 2 square minus I 5 whole square. Whole square of this is minus 5. Minus 5. When it comes out to become plus 5. So this is what we get. So these two terms will get cancelled. We left 6 plus 9, which adds up to 21. So I should be getting 21. I should be getting 20. So it should be option A. Should be option A. Yes. And the last question for this week now. The expression fx is in cubic x, where the coefficient of x cube is 1. If f1 is 5, f2 is 8, f3 is 11, is very much like the first question we had seen. X cube expression. If it is x minus 1 into x minus 2 into x minus 3 plus 3x plus 2. 3x plus 2. This is the general form of the expression. The detailed explanation is present in the first question. You can go back and look at that. From this, if you're looking at F4, we will get 3 into 2 into 1 plus 12 plus 2. Altogether, it will add up to 20, which should make a final answer. Hopefully, you learned something. Hopefully, there were tidbits that got refreshed in your head. There were potential errors that you could make that have also been talked of. So, hopefully, you learned something. See you again next week with the second part of this video, second part of quadratics. That will be all for this week.